The next speaker is extraordinarily important in a way that Jana was extraordinarily important to us. Mr. Martinson, who works with Universal Electric. Actually, Universal Electric opened our eyes to a very interesting phenomenon, that not only is DC important in Jana's world, but it's also extraordinarily important at the apex of the pyramid, where really major companies are using DC for a variety of good reasons. So I've seen some of Mr. Martinson's work. He's been doing this, he's been here as pioneer with some of his colleagues here in making DC something that all of us are beginning to understand has enormous potential. And Universal Electric is a big player in that. And with that comment, if I could just have Mr. Martinson give us a perspective on DC power that should be able to inform us excellently in terms of what will go on. And Grant, I forgot to say thank you for that visionary but a little scary speech. But I think we needed that to prod us to action. And thank you so much. And Tim, if you would be so kind.
Good morning.
Good morning.
I have to tell you, I speak to people all the time. Rarely do I have the opportunity to address an organization like this. This is awesome. And be in Prague, oh my gosh, I got lost yesterday, and it was wonderful. I plan to get lost again on Saturday. It's tremendous. And John, you didn't tell me that I didn't have to do PowerPoint, that I could just simply bring props. So this is the winner, AC. No agreement on voltages, no agreement on frequency. This is the loser. Really? So in your papers you say AC 1? Well, maybe not yet. While we work on our slide deck here a little bit, I think the message that I wanted to get across very simply is there are lessons learned. The first 3 slides, picture of Mr. Edison, the picture of Mr. Westinghouse and Mr. Tesla, and then a few quotes from industry. We bring power to data centers. That's what my company does. We distribute power safely, AC and DC power safely to industry. The initiative started back in 2003 with some ideas on how to use higher voltage DC directly into computer chips. As we went out to discuss this possibility with customers, the AC industry reacted. Well, what was interesting is not only did the AC industry react, but the world, as we spoke to them, reacted. The first thing I had to deal with is Mr. Edison invented electricity. No, that's not true. Ben Franklin found this natural force and documented it, and many others around the world worked on electricity. Then Mr. Edison invented the light bulb. No, that's not true either. There was other light bulbs invented many years before Mr. Edison came up with his version of a light bulb. And actually, some of the other components that he used eventually to create the first system were created by others. He understood that he was trying to create a better answer. The better answer was not competition with Mr. Westinghouse. It was actually to compete with gas lights, of which he started to become successful. Let's talk about Mr. Westinghouse for a minute. Mr. Westinghouse did not win the order at the Chicago World's Fair because of safety and efficiency. I've actually had people tell me that. He won it because he was low price. It's not a business case. He also won it with the help of Mr. Tesla in partnership. So as far as a lesson learned, partnership is very important. So in our industry, we've realized that not everybody wants this change to happen. There are very large companies that are very, very nervous about this type of change. They've built an entire industry on power quality products, dealing with the idiosyncrasies of AC power. And now that they've solved all those problems, the idea to simplify, to go to DC, is something that is very nervous for them. They don't want it to happen on their watch. Behind the scenes conversations with some of these major industries, they all agree eventually it's all going to be DC. In fact, one of the quotes on my slide deck is from Virginia Tech, who did a study of the commercial office buildings in the United States. So when somebody says, Mr. Westinghouse won, the AC industry won, well, 85% of the power going through a commercial office building in the United States goes through a semiconductor, which means 85% of the power is DC. The transmission of power is AC. Thank you. A little readjustment here. And so I guess lesson number one, not everybody wants to change. When we brought this idea out in 2003, 2004, immediately the AC industry came back and said, well, what about safety? What about reliability? Nothing exists. Of course, we understand this. Expense. We can't find products. Wait a second, we've just started. We understand we have to develop products and standards and so forth. Oh yeah, standards. And who's going to put this stuff in? Who's the labor force? Who has expertise? There's a long list of other things that have to be done to change something so fundamental about utilizing AC and DC products. And where can I see one operate? They saw some early proof of concepts developed, and this is a slide that depicts what we've seen back in 2003 on forward, where the idea started, trigger technology. I borrowed this slide from ABB and HP, who presented this at the Silicon Valley Leadership Council last year. I didn't put their name or their company logos on it because I've altered it so much. I didn't know if they want me to or not. But it was a great point. The idea that was talked about when we started this whole initiative was efficiency. Green power, efficiency, all of the things that were discussed so far. The expectations were very high. The AC industry was very nervous. There was a group called the DC Power Partners, which is a group of engineers of distinguished companies that came together to talk about this and move it forward. I had the opportunity to address this organization back in 2009, and I was able to introduce another organization at that time called the Emerge Alliance. And I looked in the room, and there's all these engineers, and I'm a marketing guy. So what's this marketing guy doing with all these engineers? And they all recognized that getting it to market now was the next step. How do you turn this around? And so while we were talking about it, the interest was declining. This was another time that something interesting came up and was fading away, to the point of a trough of disillusionment, as it shows on the screen. But the group did decide to join the Emerge Alliance. And also, ABB at that time chose to invest heavily, and Emerson Network Power chose to build products, and Anderson Power Products making connectors. So the industry was moving in the direction. The Emerge Alliance is an organization dedicated to the promotion of DC. DC in the occupied space, in commercial buildings, where users use the products in data centers, in outside plants, and in building services. If you look at the list, there's at least 4 companies here that are on this list that have been part of this process from the beginning. There's now over 100 on this list. So you're not alone. You're actually joining a very interesting group. And on behalf of Brian Patterson, the chairman for the Emerge Alliance, welcome. If we can help, we want to. We have been developing standards for the occupied space and data centers. We've moved forward. Notice there's a residential DC microgrid portion at the bottom, which I highlighted. There's activity already in our group to create residential standards and to look at organizations. Maybe this organization would like to help lead that initiative. These are the standards committees that we're working with. So as I started off with my props, common voltages, common frequencies. Well, DC doesn't have a frequency. So developing common voltages and voltage standards and the training around those and the communications to controls and the automation, everything that it takes to put the system together. We are now moving into what we refer to as the plateau of productivity. So things are starting to happen. It's taken a while. So, lesson number 3, selling efficiency is difficult. When I set out to sell industry efficiency, they end up talking about things like power purchase agreements. They want guarantees of results. I think efficiency is very important, but is that what it is that's most important? I think I heard some things earlier that indicated that efficiency wasn't necessarily what's so important. It's about the humanity is what's important. That's what we're really trying to deliver. It's not electricity, it's light, it's education, it's quality improvement that energy can help with. And in our world, our customer is IT. And as my company would like to look at it, the chip. What does the chip need? Well, the chip needs DC power. So from that perspective, from chip to grid, not from grid to chip, we're finding that what do they need? How can we help them? What is their business case to help us move forward? So now we tell the story differently. This is a simple graphic description of what is out there today. So AC power, 480 volts AC, is actually peak to peak 678 volts. In a DC UPS, or a UPS, they step that or change that to DC 540 volts. They then convert it back to a lower AC voltage, and then inside the power supply for the computer, there's a 380 volt DC bus that's been there for years. So if you need 380 volts DC, what are we doing with all this AC feeding it? And then from 380 volts, it goes to 12 volts. So what we simply do is we stop this conversion process early and distribute DC through the data center. And so what is the value proposition? Well, first of all, we would never put anything out there that isn't safe. Safety's not an option. Back in the day of Edison and Westinghouse, there were no standards and they went forward anyhow. And we all know that some terrible things happened for many, many years. So there are standards. The eMERGE Alliance now is speaking about what we bring to industry from an increase in reliability. Less capital expense up front. Money is important. 33% less floor space. It's less to operate, so less equipment to maintain, there's much less components. And oh, by the way, it is efficient too. So we are sensitive to it. It's simply not what is the reason to change. And at the bottom, which some people might think should be at the top, alternate energy, solar, wind, fuel cells, microturbines, which all have DC buses inside of them with power electronics, is more easily integrated. And this is a slide, by the way, from Intel, put together to tell this story. So from the chip perspective, Guy Ali, who's part of our group, and also leading the DC Microgrids Initiative, moved forward. Syracuse University worked with IBM and Capstone to create a green data center back in 2009-2010. Had the opportunity to speak at their event about this facility coming up the 17th of October. The results were phenomenal. Huge energy savings. They have distributed generation on site. Our friends ABB, when they weighed in, the industry paid attention. Green.ch, which I was privileged to visit on my way here in Zurich, has published results on the benefits of efficiency and the improvements up and running. There's IT equipment available. Here's a short list of what IBM, HP, and others have on the market. So we are winning. Have we won yet? No. But we've made great progress. So the last question, where can I see an installation? My company is committed to this. We're moving forward. We're putting our own data center online. We have an experience center which we can see how this all goes together. So somebody can walk into a US-based operation and unplug and turn things on and turn things off and play with it. It's safe. We've also been awarded a contract to move forward with a major data center in the United States, which we hope to be one that was first come to see a large installation. So in closing, lesson number 1, not everybody thinks it's a good idea. We can learn from George Westinghouse. It is about partnerships. We need to work together to change something so fundamentally different. It terrifies people, but it's important. And know the customer. Treat them with respect. What are we really providing? What is really the opportunity? We found, and I think I've put a couple notes here together, a couple US statistics. Through no fault of their own, we have many people that are poor. Those people tend to be less educated. They tend to be sicker than most. They are leading a life that is not very good. So can we provide education? Can we provide light? Recently, I was talking about preparing for this event, and John, you really set me off by saying, would I speak here? I started reading things that I've never read before. Took time out of my technology world and said, what's the humanities side of this? And as I was explaining to a fellow eMERGE member, who was a gentleman that works for Bosch, who actually grew up in a village in Slovenia that had no power, I was touched. And I said, would you share with me, from your perspective, when you were a child, what that means, what that would mean for you if we had electricity? And this young man, by the way, came from Slovenia, went to the United States with his family, got his double electrical engineering degree. So he understood exactly what we're talking about. And he says, you know, as a kid, if I could see the bugs in my water, that would have been phenomenal. I just can't imagine that. So from a customer perspective, our customer is those folks, those people. And look how bright he is. They are very bright people who, given the opportunity, can change the world. And as a gentleman pointed out last night, there's billions of them out there. How can we make a difference? So I believe DC Power is here to stay. It can make a difference. And I applaud your efforts for taking us down this path. And I thank you very much.
Tim, thank you for getting us all on the same page with that brilliant presentation.